Yeah, so I guess like it's pretty cool that we can use like emerging technologies such as natural language processing and generation, especially in the domain of like news and journalism. And this is work done during my fellowship at the New York Times. The title is Consistent Open-Ended Question Generation from News Articles. And this was done in joint collaboration with Justin Lewis and my PhD advisor, Smaranda Murishan at Columbia. So before beginning this talk, I want to like motivate like the recent work on question generation has largely focused on factoid questions such as who, what, where, when, about like basic facts. And generating open-ended questions such as why, how, what, etc. That is questions that require usually like long-form answers have proven more like to be difficult. So this is like a real-life example of open-ended question, like say if someone asks like, what's the risk of getting COVID-19 after vaccination? Like it's very unlikely that we can answer this question using like a couple of keywords or like any answer that's like very short form. So this requires like a lot of elaboration and like a detailed long-form answer. So why is like generating open-ended question like really challenging? So to obtain the central idea of a long piece of text, one usually asks an open-ended question, which can essentially be viewed as like an extreme summary of the text in the form of a question. So like let's say you have like a long piece of text, and then through an inquisitive or an open-ended question, you're basically summarizing the central idea in the piece of text. And the ability to generate such questions is particularly difficult because the generated questions must be answerable. Like you just can't randomly ask a question which doesn't really make sense. The question has to be answerable, but at the same time, one of the really important facets of using NLP in journalism and tech is that it needs to be faithful, that you cannot like make up random facts or you cannot hallucinate, which is one of the major problems of like current AI tools and techniques. So the question generated has to be faithful to the given input text. And just to like show an example of like what is the current state of art for these sort of like question generation methods and why we wanted to work on this problem. So see this input, like the variant from South Africa known as B.1351 could make things even worse for the vaccine push. Given the speed at which the variant swept through that country, it is conceivable that by April it could make up a large fraction of infections in the United States. So this is like given this input, like a basic state of art like question generation that is like trained on factoid questions, like just asks what is B1.351. Now this is not very interesting, right? And like this input is not even the answer to that question. Similarly, like if you just train on like a bunch of these like question answer pairs, like one of the major problems is like these sort of generative language models are trained on like data from like an earlier timestamp. So in a pre-COVID world, it doesn't really know anything about coronavirus or like COVID. So you see the question generated by the state-of-art model is what's going on with the Ebola virus, because there's been a lot of like text in the pre-training about Ebola, so it's probably has idea about what an Ebola virus is, and it basically associates that in terms of generating the question. So this is of course not acceptable to be deployed in a real-time system, especially in the realm of journalism. So our contribution is we like develop a novel end-to-end system consistent for generating open-ended questions that are answerable from and faithful to the input document. And we also like along with it create an evaluation data set of around like 529 paragraphs which spans across like diverse domains along with human written open-ended questions, and these were also like verified by like folks at the New York Times R&D. So to like just begin with like how do we like train such a system, like one of the things is like there is no like data to train these sort of systems, and like especially when it comes to like open-ended questions. So we rely on one of the recent contributions from NLP, like there's been prior work by Facebook Research where they introduced this data from Reddit. This subreddit particularly is called Explain Like I'm 5. And you see like one of the very intriguing and interesting aspects of this subreddit is like it has exactly the same sort of like question answer pairs which we're interested in. Like it's very like open-ended, inquisitive, and you typically require like long form answers for this. Like I want to show this example. Like if someone asks me like explain like I'm fine, why do batteries lose charge when they're not being used? And then like someone like replies to this post, and then people can upvote or downvote this. So like there are like top answers which are paired to these sort of like inquisitive open-ended questions. So it will be like we input a given like paragraph of text, and then the output will be the generated question. So let's see a little bit detail about how we go about doing this. So let's say like we have this like input answer, like advertising, mostly the funds were used to run campaign offices, buy materials, etc. And then this is paired with this like question from the LI5 subreddit: where do presidential campaigns donations actually get spent? So this is the data that's already coming from LI5, where like the question answer is paired. Now for us it's very important to like focus on factuality, right? So when we take this like data already, so from the question we use an algorithm which is Yake. I'll not go into the detail of the algorithm, but what it does is it identifies like very salient span from the question. So where do presidential campaign donations actually get spent? If you feed this to Yake, so it gives you presidential campaign donations. So in the next step, what we are going to do is, so we are going to take this presidential campaign donations and the answer, and we are going to feed this both together to the encoder of our model. And the reason for including presidential campaign donations is because this is a salient and important aspect which we want to be in our generated question. So this is like some sort of supervision which we want to provide to the model. If we just provide the model the answer, then there is chances that the model can like make up hallucinated facts, right? So we want to provide some sort of like explicit control code which will lead the model to like generate a question which will actually incorporate the presidential donate campaign. So as I was telling you about the sequence to sequence model, so here the input that goes to our model is the presidential campaign donation as a control code and the answer to the encoder, and then after training the decoder basically generates this: where do presidential campaign donations actually get spent? And here I'll talk a little bit more in detail about like how we actually generate this question. So I'll start like in a step-by-step procedure. So let's say after the model is trained, now we want to generate like open-ended questions which are factual and good in quality. So how do we do this? So let's say this is an article paragraph, like it was the kind of conversation happening in group text, Twitter threads, Zoom rooms, etc. And then, so what we first do is like we use the Yake algorithm to identify salient like key phrases such as Twitter, Bitcoin, digital currencies, one niche word. So these are all like control codes which we want. Like along with the article paragraph and these control codes, we feed this to the like model that is trained on our data from ELI5. So now through this procedure, the model can generate a lot of questions. Like some of these are good questions, some of these are bad questions. So a couple of questions is: what was going on at Twitter? What are Bitcoins and how have they made a lot of people very rich? How has the once niche world of digital currencies invaded the mainstream? So you can see like these are all very like grammatical, fluent and coherent questions, but not all of them are actually good. So I think like for journalism or like these sort of like use cases where factuality is very important, it's also important for us to like evaluate the quality of these generated questions. So again, like there is no like prior data or trained model through which we can actually like evaluate this. So what we do is like there is prior work on like question answering, where like given an answer in a question, you can tell if it's like with what confidence you can tell that it is the like probable answer. And this is just like boils down to like basic probability theory, where given a question and an answer, it can give you like a confidence score from 0 to 100 that what is the probability that it's an answer. So given all these questions and the article paragraph, and we feed this to the model, it gives us different sort of confidences. So you see for the what are bitcoins, how have they made a lot of people very rich? Like this is a very coherent and fluent question, but then the answer to this is definitely not in the article paragraph. So it's very low in terms of confidence, only like 33% confident. Whereas the third question, like it gives a threshold of around like 93%. So basically it means that the model is confident that this question can be answered from this paragraph. And again, like there could be like a lot of such questions which the model initially thought were confident. So we use another filtering mechanism which is based on like current prompt-based techniques in NLP. Like I guess a lot of you have been familiar about GPT-3 or these sort of like models where you just give it like an instructional prompt and the model gives you like an answer. So what we do is like a simple prompt that given paragraph XP is the question Q and answerable. Please answer in yes or no. So then the model basically gives you an output. It's either yes or no. So through this like two steps of primary filtering and secondary filtering, we finally get like the best high quality question, which is here the third question. So for evaluation data, like of course like we build this model, so it's important for us to like evaluate like these sort of like questions, and then there is no like existing data set where we can do this. So we use like so we created evaluation data sets of around like 529 paragraphs across like diverse domains of science, climate, technology, health, business, etc. And then we collect this first using like crowd workers on Amazon Mechanical Turk, and to ensure further quality, we also like verify them with team members at the New York Times R&D, who then like ensure that the quality is really good. So like just an example is, like for this input, it's springtime of pandemic. After the trauma of the last year, the quarantined are emerging into sunlight and beginning to navigate travel, classrooms and restaurants. And they are discovering that when it comes to returning to the old ways, how many feel out of sorts. Do they shake hands, hug with or without a mask? So like a question that is open-ended, actually written by human and verified by the people at Times, is how are people adapting to life after the pandemic? So you see this is like an open-ended question which you basically cannot answer using one keyword, so you need like a elaborate descriptive answer. So we have like a bunch of baselines for this. Like for us, like one thing is like often what happens is like in a paragraph, the first sentence itself is like the giveaway. So like, can you just take the first sentence and convert this to a question? And then one thing is like where we do not really control for factuality, we just like train a model on the data. And then one method is just we train on like a prior work on like factoid questions. So for evaluating this, we basically use like some sort of like automatic metrics which basically takes similarity between the generated question and the goal written question by the humans. But automatic evaluation is not perfect for these sort of generation use cases. So we also have 3 distinct members from the New York Times R&D who take these generated questions from the model and then evaluate them, like if the question is good, bad, or the question is like basically cannot be used. So I want to like show the evaluation for generation. I'm not going to take a lot of time in this, but as you see that there were like at least like 5 very strong competing baselines, and in terms of automatic evaluation, our like current method came out to be the best. And we took the top 2 performing system based on the automatic metric and evaluated them with expert at the New York Times R&D team. And then you can see that overall, basically our system like generated questions that were preferred by experts 48% of the times, and then the model, which was just the baseline without any like control for factuality, it was only preferred 15% of the times. And then there is still cases, there are 11% of the times where both of the models couldn't generate something good, and then 25% of the times where both the models were good. So this sort of shows that our method is sort of like pretty impressive. And I want to show this example where this input we already showed, and you can see the output of all these various systems. Like a lot of them are actually generating like randomly made facts, which is the random out says, why is the domestic product of the flu so bad right now? So this sort of shows that why factuality is really important. And our best system, consistent, generates what does the variant from South Africa mean for the vaccine push, which is actually the exact factual and like grammatically correct question for this input as a paragraph. So this shows the reason for us to build these sort of models. And before ending this talk, I want to show like some sort of like real life examples on why we are building these sort of system and how this might actually impact journalists at the Times, which I think Jack will also add a little bit about. So this is like a prototype admin tool where we are not generating these sort of like questions using AI models, but of course we don't still have that much of trust in AI models to directly deploy them in a system, especially in a firm like New York Times, which really cares about like factuality and truthfulness. So what we are going to do is like, we can still have these sort of news articles and generated questions by these models, and then like a human or an editor in the loop can just like sit and then accept or reject these sort of questions. So you see for this J&J vaccine and blood clots, like there are several sorts of like questions like, what is a blood clot and how does it get to the brain? So this is not really a good question, so maybe someone can reject it. Or like, this question is really good, how do experts keep track of any medical problems experienced by people who receive vaccines? So like, these are actually all generated by our models. So then like a human could basically accept or reject it. And another use case which we really thought is like, cool, like these sort of generated questions can actually be used in terms of search. Like people really, like when they search for things, they type questions. So like if we can anticipate what sort of questions people can ask, we can pair these generated questions to actual news articles. And we see here that, say even for article recommendation or related articles, you see the related articles have like questions in the side. Like for a given Johnson & Johnson vaccine offers strong protection, like we can have like questions and paired news articles, which can then like lead people to like click on these sort of things, because when they see a question, they're usually inquisitive and they want to know what's the answer for this. But then it's sort of like manual for like an editor to just like go and sit and write these questions. But if you have these sort of automated questions, these can be used in search or article recommendations, because in Google what we do, we often like type questions, right? And Google has all history of those questions, which it then indexes to like improve the search experience. So, but then it's like very manual for like a human to write all those questions. If like the AI model can anticipate that and generate these sort of questions, then we can filter the good or the bad ones and then like use this to improve the search quality. Yeah, so that ends me to the like end of my talk, and this is work that is going to be like presented at a conference in December. And the paper is going to come out online in like a few weeks, so if any of you are interested, feel free to reach out to me or any other members of the team. And with that, like, I'll leave it to Jack, and we can talk more about like where this sort of lies in the, like, where is NLP in the news domain and how it can impact and improve like journalism tech. Thank you.
Yeah, maybe before we take a couple questions, I just wanted to add to that. So, hi everyone, I'm Jack. I'm from R&D. I lead a lot of the work that we're doing on natural language processing, and I just want to reemphasize that the work that Tuhin has done has been really interesting, I guess, and just cool to see it get done. As Tuhin mentioned, there's like a lot of immediate applications for us. So one of the earlier slides that you showed with the coronavirus FAQ, where you had that question, like I forgot what the exact question was, but it was like, what? Yeah, it's
what
only.
What are the long-term effects of like vaccine?
Yeah, this one. Yeah. The what's the risk of getting COVID-19 after vaccination? So this is a screenshot of an NLP project that we published pretty recently, where we had a bunch of questions about COVID-19, and we had a little module at the top where readers could actually type in a question that they had about COVID, and we would try to match it with an answer that had been written by a New York Times journalist. And so this was a really kind of cool and innovative application of NLP at the Times. And Tuhin's work of generating questions from long-form articles is something that we're kind of looking at as speeding up the deployment of future iterations of these. So if we were to launch FAQs on new news topics, and we're trying to like anticipate what types of questions our readers will ask, we would kind of turn to this kind of tool. So I just wanted to highlight that. It was like a pretty cool and interesting application of Tuhin's work. But yeah, we'd love to field any questions.
Yeah, sure. Maybe we can take your question first.
So I have two quick questions. First, what does integration of a tool like this look like for a search engine such as Google or Bing? And then my second question is, how does this system interact with popular terms within pop culture? For example, like when Merriam-Webster releases their new definitions at the end of the year, many of them are pop culture terms. How would a system like this?
Yeah, that's a great question. Like, to answer your first question, so I think you asked like how this like impacts search. So one of the like goals of search is to like make sure to like, so it's sort of like a relevance ranking problem, right? Where you basically ask a question and there's a bunch of articles. Like, so in Google or like in a lot of other like social media search, like basically this is a very iterative process. Like for a new topic, when you first search something, there's nothing. And then like as people like search more, new articles appear, and then like these sort of like techniques are like re-ranked and updated again and again. So for our approach in like generating questions, this is like very helpful. So say supposedly like when there's like a first topic about like flying after like the vaccine, so like there was like a huge pause on like flying internationally like till during the COVID period, right? So people are asking different sorts of questions like, is it safe to fly after vaccination? When can I finally fly after vaccination? Can I? So like these sort of questions are like sort of very paraphrase of like one particular question, right? And then to anticipate like what a user will ask, like there cannot be a human sitting who can anticipate all these questions. So, but then what a model can do is like it can generate infinite number of such questions. So given a particular news article, like through statistical sampling or like from the model. So now if there is someone who is like approving these questions and then finally adding this to like a database, and it's like pairing this to like an original news article, then in future when someone will ask this question, then like they will be shown this article, which before these sort of like indexing or updating would not happen, right? So this is some way we are sort of trying to reduce a little bit of the manual effort, because it's not possible for like someone to do, and Google does that, like where they have like, they basically like take all the questions or all the search results you do to like consistently improve their search. So I think like at New York Times, probably we don't have that level of scale, or there is also like probably, I don't really know like in terms of privacy how much data we can save, but like this sort of like generative models can sort of augment this process. And your second question on pop culture references, so the underlying model that is being used to train is a generative language model. So this is already trained on a lot of data from the internet, like public web data. So I'm sure like it already knows about like pop culture references. Like if you ask about like an artist or like a movie or Star Trek, it already has that sort of like encoded world knowledge or common sense in its parameters. Like that's one of the inventions of like these days NLP, where like there are like large language models like GPT-3, or like in our work we use BART. So these are trained on a lot of like pre-trained on public data. So it definitely knows about like these sort of references. But what our work is also helpful is because it specifically cares for factuality. So if there is like a pop culture reference you want it to generate or include in its question, and if you have that sort of as a control code, then it will actually have that in your generated question. So yeah, I mean, we also really care about controllability. We just don't want the model to generate anything it wants. So there is like specific supervision. So yeah.
One more question.
Yeah. I think you asked your hand.
I can wait for the network to break.
Yeah, I mean, sure.
This is for either of you. This is amazing work. It's very fascinating. Some of us in the audience are from museums. I see a lot of potential here, especially for kid questions. But I'm just fascinated. This is coming from the New York Times. What I wonder is how do journalists feel about this? This feels like further nuggetization of content and potentially losing context in like a long form article. Are you concerned there's like an order of operations here where people will skip articles and go right for this question and like look for the bite-sized content as opposed to maybe learning more about the story? I just, like, where's the balance? Where do you see this going?
Take that?
Yeah, maybe you should.
Yeah, sure. That's a really good question. This is a bit of a prototype. So we've launched like 2 of these on articles about COVID, and the idea isn't necessarily that it's like detracting or distracting from all our COVID coverage, but more that it's kind of helping people find pertinent health information. And so we're looking at launching these on a couple more stories this fall, published by the business and climate desks in the coming weeks. And I think journalists are actually pretty supportive of it. And there's a couple of reasons for that. One of them is that it is kind of helping, like, especially for stories with longer timelines. You know, like, for example, if you think back to like 2020, around the beginning of COVID, if you wanted to know the latest health information about every aspect of COVID, like, you know, what type of mask to wear, like, you know, whatever, you had to read so many news articles just to stay informed. And this kind of helped people like get their foot in the water. But then the other thing is that these kinds of tools can actually influence coverage. So like, for example, for that module that I had talked about, by fielding questions from readers, we actually were able to learn about which topics readers were interested in that we hadn't covered as well. And that's even another application of Tuhin's work, like kind of helping us find our blind spots. Does that answer your question?
Yeah, a little bit.
Yeah. Okay. Well, we can kind of, yeah. Let's talk later as well.